Okay, now let's go to the second part. Here we will talk about the VI relationship for inductor. Alright, so for the second part, we will now assume that we have an inductor, okay, where it starts from the positive to the negative. This is the current for the I, and you have the value of the inductance L. Okay, so now we have learned actually before this that the relationship of the voltage, okay, inside the across the inductor is given by L di dt. Okay, so you can say that when you have the voltage here, okay, from the positive to negative, then we have this V equals to L di dt. Okay, and we also have talked before this that the I actually equals to the Im cos omega t plus theta I. Okay, so now how are we going to differentiate this current, okay, with respect to the time? So this is actually need to have understanding on the differentiation. Okay, so I will revise about the differentiation part here. Let's say here I will consider that the cos omega t plus theta I now is given by Im cos u. So in this case, I assume that u equals to omega t plus theta I. Alright. Now, when we have this equation, I will differentiate this u with respect to t, where I will have only omega, right? Now, I will also consider that if I have I equals to Im cos u here, okay, what happens if I have here, if I have I equals to cos u, Im cos u. So if I have di du, then I will have I negative sine u, right? Okay, based on this, then I can find my di dt using the chain rule. So you have di dt equals to di du multiply with du dt. Okay, and when I write about this again, I have Im, okay, negative sine u. So I have negative sine, and I know that my u is omega t plus theta I. Okay, so I write this as the result of di du and multiply with du dt. So I have du dt is omega. Okay, so when I rewrite this equation, what I will get is the value of this one becomes V equals to L di dt. So I will have L multiply with di dt, which is L Im, and we have negative here, right? So you can put the negative, okay, outside here. So we have negative L Im, and then we have sine omega t plus theta I, and you can also see the omega here. So I will put this, let's say the omega is here. So I have negative L omega Im multiply with sine omega t plus theta I. Okay, and because we need to have a function in terms of cosine, then I will write this V. Now it become, okay, I will put the omega in the beginning. So I have negative omega L Im, and we know that the relationship of cos and sine is sine omega t plus theta I equals to cos omega t plus theta I minus 90 degree. Okay, so I put this bracket again. Now, what you can see here, okay, the value of omega t, okay, the value of omega t is here, and we have another one is the phase angle of theta I minus 90 degree. So when I write this v in terms of the phasor transform, I will have the capital V here. Okay, now it becomes negative omega L, and we also know about this Im, so we have Im, and what is the phase angle? It is theta I negative minus 90 degree. Okay, alright. Now, when I want to solve this value, I can actually rewrite this, okay, in terms of exponent j theta, okay, exponent j phi. So I have negative omega L. Now we have Im exponent j of this phi. So we have j theta I minus 90 degree. Alright. Now, when we have this equation, alright, I can now rewrite this v, okay, in terms of the multiplication of exponential. So I have v equals to negative omega L Im, okay, and you have this exponent j theta I multiply with exponent negative j 90 degree, right? Okay, because we have this equation of exponential. Okay, so this exponential, okay, when I rewrite again in terms of this multiplication of exponential, I will get this. Okay, the multiplication of exponents. Now, when you have this type of equation, okay, how are you going to solve the exponent negative j theta, negative j 90 degree? Okay, so for solving this one, we need to know about the Euler formula, okay, where in the Euler formula, okay, whatever that we have for exponent j theta will equals to cos theta plus j theta. Okay, if we have exponent negative j theta, we will have cos negative theta. Okay, for this one, this is not j theta. This is the sine theta, j sine theta. Okay, so when we have cos exponent negative j theta, we will have cos negative theta plus j sine negative theta. Okay, and since cos negative theta also equals to cos theta, we can rewrite as this, and sine negative theta equals to, okay, this sine negative theta, okay, equals to negative sine theta. So I can now write, okay, this one as negative j sine theta. So it implies that when you have exponent negative j 90 degree, okay, we will have cos 90 degree minus j sine 90 degree. Okay, and when we solve this, cos 90 degree is 0, and for the sine 90 degree is 1. So we will have only negative j when we write about the exponent negative j 90 degree. So it means for the, back to the notation of this v, okay, I will have the v here equals to negative J, okay, omega L I m exponent J theta I. Okay, so this is just the same because I am now replacing the exponent negative J 90 degree with the negative J. And if you look at this notation of negative, so it's actually negative and then multiply with negative J. So in that case, we have J omega L I m exponent J theta I. Okay, so in other words, I can actually say that this I m exponent J omega theta I is actually the I. Okay, because if we use the phasor transform before this, we also can say that this I, capital I, equals to I m exponent J theta I. So I can now write this V in terms of I is equals to J omega L I. So this is the relationship between the, between the V and also the I. Right. So that is for the relationship, VI relationship for inductor.